Now next, faces, edges and vertices. And you know, when two sides meet at a point, that point is called vertex. You can see here, two or more than two. Look at the following solids. You can see here edges, side, 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 and hold this faces. Okay, in the shoe box you can see faces, top, then back side, it's then side view and opposite side. Okay, front view and its opposite side. So 6 faces. You can see sides and vertex, that means corner. We can see. Riddle, I have no vertices, I have no flat faces. Who am I? Cylinder. Easily we can say that. Now see here, each of these solids is made up of polygonal regions. Polygons, what? Closed shape. Suppose that rectangle, polygon, square, polygons. So each of this solid is made up of polygonal regions which are called its faces. You can see triangle, top. These faces meet at edges, which are line segments. All the faces, edges. And the edges meet at vertices, which are points. Edges are meeting at one point. It's called vertex. Such solids are called polyhedrons. So in short, keep this thing in your mind. Polyhedrons are those who are having more surfaces, like cuboid, cube, prism. You can see solid. Now see here, these are polyhedrons. You can see solid, so many faces. But these are not curved surface, not more than 2, 3 or more than 3, and curved surface are there. You can see, not polygons are there. Here the closed shape. So how are the polyhedrons different from the non-polyhedrons? Study the figure carefully. You know 3 other types of common solids: curved surface, lateral surface, base, base, lateral surface, base. So these are not. Convex polyhedrons. You will recall the concept of convex polygons. The idea of convex polyhedron is similar. Now see here, see here, you can see, suppose that we are taking this quadrilateral. It is called parallelogram, right? When you will draw its diagonal inside, you can see the diagonal of this. Now if these are also, the diagonal definition is opposite vertex when we draw. Now you can see it's diagonal outside, so it is concave, it is convex. Same here, we are using this theory because it is written carefully. You will recall the concept of convex polygons. The idea of convex polyhedron is similar. So when you will draw its opposite inside, when you will take this and this outside, this and this you are getting outside. So these are not convex polyhedrons and these are convex polyhedrons. Okay. Now regular polyhedrons. A polyhedron is said to be regular if its faces are made up of regular polygons and the same number of faces meet at each vertex. Same number of faces meet at each vertex. So you can see here the example of cube. Okay, in the cube all the faces are square shape, so polygons, and they are meeting. This polyhedron is regular, its faces are congruent, regular polygons, vertices are formed by the same number of faces. This polyhedron is not regular, all the sides are congruent, but the vertices are not formed by the same number of faces. 3 faces meet at A. You can see four faces at B. Okay. Two important members of polyhedron family around are prism and pyramids. Okay. Children, I'll go in the science library and I will show you. Okay, with model. When I will go tomorrow in the science library and I will science lab and I will show you. Now see here, we say that a prism is a polyhedron whose base and top are congruent polygons and whose other faces, that is lateral faces, are parallelograms in shape. Okay. Lateral faces and see congruent. On the other hand, a pyramid is a polyhedron whose base is polygon of any number of sides and whose lateral faces are triangles with a common vertex. Common vertex. If you join all the corners of polygon to a point not in its plane, you get a model for pyramid. That means if we join all the corners of a polygon to a point not in its plane, you get a model for pyramid like this. Suppose that I have drawn now all the corners got pyramid in this way. Okay. Now a prism or a pyramid is named after its base. Thus a hexagonal prism has a hexagon as its base, and a triangular pyramid has a triangle as its base. What then is a rectangular prism? What is a square pyramid? Clearly their bases are rectangle and square respectively. Now see here, tabulate the number of faces, edges and vertices for the following polyhedrons. Here V stands for number of vertices, F stands for number of faces and E stands for number of edges. So cuboid. So I'll show you the cuboid. You can see this box. Okay, I'm showing this box. You can see beta. Now see here, faces. Back side. Now see here, this also, so it's the back side. This also, so it's how many faces you got in the cuboid? 6. Now vertices. See here, I am showing you vertices. you can see point 1, 2, 3, 4. Same 5, 6, 7, 8. Okay. Now how many edges? So edges find. So 1, 2, 3, 4. Just opposite of 5, 6, 7, 8. And then 9, 10, 11, 12. So how many sides? So what you will write? Faces 6, vertices 8, edges 12. A plus V. You will do E plus 2. Triangular pyramid also you will do. Triangular prism, pyramid with square base, prism with square base. Try to fill, then I will help you. Don't worry. After completing the table, when you will see, what do you infer from the last two columns? In each case, do you find F plus V equal to E plus 2? Or when you will add the faces plus vertices and subtract from the edges, you will get the answer is 2. This relationship is called Euler's formula. That means Euler's formula is equal to F plus V minus E is equal to 2. In fact, this formula is true for any polyhedron. Okay. Now think, discuss and write. It's for you. What happens to faces, vertices and edges if some parts are sliced off from a solid? To start with, you may take a plasticine cube, cut a corner off and investigate. This activity for you, you will try. Okay. Now let us start exercise 10.3. Can a polyhedron have for its faces 3 triangles? No. For polyhedron, the faces should be more than 3. 4 triangles? Yes. A square and 4 triangles? Yes. Okay. Now, is it possible to have a polyhedron with any given number of faces? Hint. Think of a pyramid. So, we know the condition of polyhedron more than 3 faces. So, if the more than 3 faces, that means should be at least 4 faces. Okay. So, we can. So, is it possible have a polyhedron with any given number of faces? Think of a pyramid. So, now see here which are prisms among the following. Curved surface. Yes, maybe. Unsharpened pencil. A table weight? No. A box? Maybe prism. Fourth question, how are prisms and cylinders alike? So we can see that in the prisms and cylinders, so circular, we can say circular base prisms. And how are pyramids and cone? So pyramids, we can say cone as a circular base pyramid. Is a square prism same as a cube? Explain. Yes, square prism we can say because all faces are maybe equal. It may be cuboid also. But is a square prism same as a cube? Yes, we can say. Now verify Euler's formula for the solids. So we can see the solids. First we count faces. So 1 on the top, then bottom 2, then 3, 4, 5, 6 and 7. So 7 faces are there. And then we will count sides. So 1, 2, 3, 4, 5. 5 top, 5 bottom. So 10 and 10, 11 back side, 11, 12, 13, 14, 15. So 15 sides. Now vertices 1, 2, 3, 4, 5. phi here and phi on the bottom. So now you will substitute the value in this formula. F plus V minus E, you will get, first you will write Euler's formula is equal to F plus Euler's formula F plus V minus E is equal to 2. Put the value in place of A, faces, then vertices, then edges, and if you are getting 2, that means you have counted in the correct way. Okay. Now see in this. Okay. First we will cite faces. So faces 1, 2, 3, 4, 5, 6, and then 7, 8, and 9. Then vertices. So vertices 4 here, 4 bottom. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 vertices. Now we will count sides. So for sides 12 we know. Okay. Because 1, 2, 3, 4, 5, 6 in this way. Already I have counted in this. I show you in this box. Okay. Now on the top. So after counting the 12, see here 13, 14, 15, 16. Now you will put the value in the formula, and if answer you are getting 2, then I taught you in the proper way. Now 7th one, using Euler's formula find the unknown. So how you will find? You can do, children, but I am only explaining here. So first you will write by Euler's formula and then dash, and you will write the formula. Formula is F plus V minus 2. Sorry, F plus V minus E is equal to. Okay. Now F is not given. Okay, put the value in the formula. You will write this like algebraic equation we have solved, na? Same way. Faces not given, so if you will write now vertices 6, edges 12 is equal to 8. 6 minus 12 minus 6 is equal to 2. F equal to 2 plus 6. F equal to 8. In this way, step by step, you can solve. Okay. So this 3 question: faces, vertices, edges. Faces, vertices, edges. Here vertices. Then faces, edges, vertices, edges here. Now, can you polyhedron have 10 faces, 20 edges, and 15 vertices? So here given, then use the Euler's formula. If you are getting answer 2, then we can draw. If answer is not 2, then you will write we cannot. Now what we have discussed. Okay. Now what we have discussed: recognizing 2D, 3D objects, recognizing different shapes here in nested objects. I will send you one definition of nested. Nested वैसे तो हम इसका मीनिंग नेस्ट, शेल्टर, शेड है ना, इस तरह से लेते हैं कि घोंसला जैसे पक्षी रहते हैं. वैसे ही अगर इफ अ व्हीकल वी आर टेकिंग, सो व्हीकल one is object and one person is riding it, so nested object, because persons is riding, that means inside the person the object is there. 3D objects have different views from different positions. A map is different from a picture. A map depicts the location of a particular object or place in relation to other objects or place. Symbols are used to depict the different objects or place. There is no reference perspective in a map. Maps involve a scale which is fixed for a particular map. Euler's formula, please keep it in your mind. It's a very important formula where F stands for, we know, V stands for, E stands for, and this relationship is called Euler's formula. So here chapter is finished. Now complete your chapter.